Immunology Insights, Basics and Beyond. Chapter 5. White blood cells, neutrophils, eosinophils and basophils. Marcello here. Welcome back to Immunology Insights, Basics and Beyond. In our previous chapter, we explored the revolutionary work of Edward Jenner and the origins of vaccination. Now, as we continue to delve deeper into the immune system, it is time to examine some of the most critical cellular components, white blood cells. Specifically, today we will focus on neutrophils, eosinophils and basophils, three types of granulocytes that form an essential part of the body's defense. These cells are key players in the innate immune system, providing a rapid and generalized response to a wide variety of pathogens. So let's talk science. Let's start with neutrophils, the first responders of the innate immune system. Neutrophils are the most abundant type of white blood cells, accounting for about 60 to 70% of all leukocytes in the human body. As members of the innate immune system, they are always on standby, ready to respond to any sign of infection. Produced in the bone marrow in response to signals such as granulocyte colony stimulating factor or GCSF, neutrophils are quickly deployed to the site of infection. Once they arrive at the scene, neutrophils use their primary mechanism, phagocytosis, to engulf and digest invading pathogens. Picture them as highly trained security personnel who swiftly neutralize threats before they can even cause significant harm. But that's not all. They also have a remarkable, albeit self-sacrificial method of trapping and killing pathogens known as neutrophil extracellular traps, or nets. By releasing a web of DNA laced with antimicrobial proteins, neutrophils can ensnare and neutralize pathogens outside of their own cell membrane. This act, however, often leads to the neutrophil's own demise, underlining their role as sacrificial protectors of the body. Interestingly, some researchers have proposed a connection between the intense production of neutrophils during an infection and the limb pain or body aches often experienced when we are sick. As your bone marrow ramps up neutrophil production, these cells rapidly move into the bloodstream, possibly contributing to the sensation of discomfort as they pass the periosteum, the membrane covering all bones, and then flood the circulatory system. Next, we have eosinophils, the parasite killers and allergy mediators. While neutrophils take on the role of first responders, eosinophils have a more specialized function. These cells, which make up about 1 to 4% of white blood cells, are particularly effective against larger parasites, such as helminths, a type of parasitic worm, that are too big to be engulfed by phagocytosis. Like neutrophils, eosinophils are part of the innate immune system and are also produced in the bone marrow, typically in response to interleukin-5 or IL-5. When eosinophils encounter a parasite, they release a barrage of toxic granules directly onto the surface of the invader, effectively destroying it. However, this potent weaponry comes with a risk. If eosinophils release these substances inappropriately, they can cause significant tissue damage. This is precisely what happens during an allergic reaction. Eosinophils mistakenly target harmless substances like pollen and contribute to symptoms such as inflammation, itching and redness. As a side note, also mast cells, like eosinophils, play a key role in allergic responses. Though not circulating in the blood like other granulocytes, they reside in tissues, particularly at the sites of potential pathogen entry. Mast cells release histamine and other inflammatory mediators upon activation, driving the hallmark symptoms of allergies. This activation is often triggered when immunoglobulin E or IgE, a type of antibody, is produced in response to an allergen and binds to the receptors on the mast cell's surface. We will come in a later chapter of this podcast to the different types of antibodies and their functions. Together with eosinophils, mast cells contribute to both the early and the late phases of allergic reactions. In comparison, eosinophils are more involved in the later stages of allergic inflammation, helping to sustain and amplify the immune response. whereas mast cells initiate the immediate response. Both cell types are part of the granulocyte family, but mast cells, unlike eosinophils, are stationed in tissues rather than in the bloodstream. Beyond their role in direct pathogen defense, eosinophils are also involved in shaping the immune response. They communicate with other immune cells, influencing the overall direction and intensity of their response. In chronic infections and conditions such as asthma, eosinophils play a crucial role in regulating inflammation, the double-edged sword that can both protect and harm. Last but not least, we come to basophils, the alarm bells of the immune system. Basophils are the rarest of the granulocytes, constituting less than 1% of all white blood cells. Despite their low numbers, they play a vital role as part of the innate immune system's rapid response team. Produced in the bone marrow and released into the bloodstream in response to signals like interleukin-3 or IL-3, basophils act as the immune system's alarm bells, particularly during allergic reactions. When basophils encounter allergens, also they release granules filled with histamine and other chemicals that trigger inflammation. This response helps to expel the allergen from the body, but also leads to the symptoms that we commonly associate with allergies: swelling, redness, and itching. Basophils also play a role in defending against parasites, working alongside eosinophils to combat these larger invaders. What makes basophils particularly interesting is their close relationship with mast cells. While basophils circulate in the bloodstream, mast cells reside in tissues. Together, they coordinate a powerful response to parasites and allergens, ensuring that the immune system is ready to act swiftly and efficiently when needed. To conclude, in this chapter, we have explored the roles of neutrophils, eosinophils, and basophils, three critical types of granulocytes that form the frontline defense of the innate immune system. These cells are produced in the bone marrow and are essential for responding to infections, fighting parasites, and mediating allergic reactions. Despite their differences, they work together to ensure that our bodies are protected from a wide range of threats. As we move forward, our journey into the immune system will take us from these generalized defenders to the more specialized cells. In the next chapter, we will explore monocytes and macrophages, the immune system's versatile warriors. Stay with us as we continue to uncover the incredible complexity and coordination that keeps us healthy every day. Before closing, I have a small request. If you enjoyed my content and want to hear more, like and subscribe. It's a small step for you, but it helps me a lot. So, see you next time, and thank you for listening.